So welcome to part 2 on how to factor by grouping, and we are talking about cubics. So the first thing you want to see, does it have a GCF? So is there anything in common between your 4 terms? And then if there is not, you're going to factor by grouping. So you can factor by grouping when you have 4 terms. But that is it. So on problem F, I have a z cubed and I have a 20. I immediately know they have nothing in common because 1 is your smallest number and then 20 does not have a z. So they have not a greatest common factor. So I'm going to move on to factor by grouping. If you remember in Algebra 1, to factor by grouping, you split it down the middle. You're going to ask yourself, what is the greatest common factor of the first 2 terms? Now there's a 1 here, so they don't have a number in common, but they do have z squared in common. So take out a z squared from the first ones. You will always be able to take out something squared. Take z squared from everything else. You'd be left with 1z on the inside, because 3z's minus 2z is 1z. And then you'd be left with a plus 5 on the inside, because you had 2z's, you took them away, there is nothing with this term. If you remember, this parenthesis needs to repeat on your other side. And then I'm trying to find what number times z will get you to a negative 4z. And the answer is a negative 4. Then you will take your 2 greatest common factors and write them in one parenthesis. Your parenthesis that repeated, you will write it once. And in Algebra 1, we stopped because we were done. But in fact, we can expand this problem because it is a difference of squares. So if you remember in part 1, 4 is a perfect square, and a 1 is a perfect square, and I have a subtraction, so it is a difference of squares. So to expand this problem, in blue, this will split up into 2 parentheses, and I'm going to square root each one. There's an imaginary 1 here. The square root of a 1 is a 1. So if I square root z squared, I'm left with a z and a z, because z times z is z squared. The square root of a 4 is a 2. And then remember, your signs have to be different. 1 has to be plus, 1 has to be minus. It does not matter the order. Your final step is to bring down your z plus 5, and then you are done because you have factored it completely. Okay? All right, let's do another example. On G, first thing you have to ask yourself, is there a greatest common factor? A key is this number is massive, okay? So there's probably something they have in common. Let's see if 3 divides into all of these. And in fact, it does. So I'm going to take a 3 away. I cannot take a variable because there is no variable with this term. So take out a 3 from everything. We're going to divide everything by a 3. Leaves me with p cubed. Negative 12 divide 3 is negative 4. P squared. Negative 27 divide 3 is negative 9. P. And then 108 divided by 3 is 36. Okay, so to get those numbers, we are dividing by 3. Now, this first parenthesis has 4 terms. There is no greatest common factor, so I'm going to factor by grouping. So I'm going to split this problem in half. This 3, I'm going to ignore it for the moment. It's going to be in my final answer. So what do these 2 terms have in common? They have a p squared in common. If I take a p squared out, I'm going to have p minus 4. That parenthesis has to repeat, p minus 4. Then I'm going to ask myself, what times p will get me to a negative 9? So it's just a negative 9. And then to write my final answer, my two greatest common factors get their own parenthesis. The parenthesis that repeated, you write it once. And then do not forget that 3 does come down for your final answer. Now, I have to figure out if I can expand any of my parentheses. This one right here is a difference of squares. So 9 is a perfect square, and we know that p squared is a perfect square. So, if I expand that parenthesis, I'm going to do it over here in orange. The square root of p squared is a p and a p. The square root of a 9 is a 3. And then 1 plus, 1 minus. And then drop on our last parenthesis, p minus 4. And then don't forget to drop down that 3 in your final answer. So I am done. I have factored every single parenthesis as far as I can. All right, we've got one more. All right, last one. I've got 4 terms. Now, this one tripped me up when I was making an answer key, not going to be honest. I was like, let's go ahead and factor it by grouping. But if you notice, it is not in order. Okay, it's not in standard form. So we need to put it in standard form first before I can factor by grouping. So highest exponent goes first, x cubed. Next highest exponent is x squared, followed by your x term, and then our number, -48. So now, if I ask myself, do they have anything in common? No, because that's a 1, and then this one does not have a variable. So they have nothing in common, no greatest common factor. Let's factor by grouping. So the first two, they have an x squared in common. If I take an x squared away, I'm left with 1x, and then plus a 3. Your parenthesis must repeat. And then ask yourself, what times x is -16x? It is a -16. We're going to write our greatest common factors in one parenthesis. The parenthesis that repeated, you will write it once. Now, let's see if I can expand anything. This x squared minus 16, again, is a difference of squares. Let me abbreviate. Difference of squares. So I can expand this parenthesis into 2. And then go ahead and drop down this last parenthesis. So if I expand this problem, I'm going to have an x in each one. 1 plus 1 minus. And then the square root of a 16 is a 4 and a 4. So now I have factored it completely. And if you want to have a connection to what we've been doing, we could graph it, we could talk about end behavior, I could find the zeros, all from factoring it. So there's a benefit of taking a function from standard form to factored form, so you can graph it easier, you can find the answers, you can find your solutions. So thank you for watching a video on factoring cubics. If you have any questions, let me know. Any practice we do for this topic, I need you to show me your work because Photomath is amazing at doing this. So if you want any credit for practicing, do show your work. Have a great day.